Hello, everyone. Uh, Welcome to a regularly scheduled API review where once again we have things marked as blocking. Uh, I'm at least partly to blame. And um, we have some other 6.0 issues, but we're not really expecting to get past the red today. So, let's jump right in, shall we? All right. General purpose non-cryptographic hashing API for .NET 24328. This is something we already approved. I'm almost done with the implementation on it, and there are some things that came up that make me want to change the API. So in the non-cryptographic hash algorithm base class, we have this property hash length in bytes, and then we have all of the span writing methods returning the number of bytes that they wrote, which is all well and good. We also have the template method pattern, so we have get current hash core. Since that was returning an int that's supposed to match the property, I found myself checking it and throwing if it didn't match, which I decided was stupid, and I just made the method void. So the get current hash core and get hash and reset core change from int to void, and the derived types have to write the number of bytes they promised they were going to write. That is just part of the API contract. Anyone have feedback on that one?
Approve.
Cool. All right, and then the second piece. So we approved four algorithms: CRC32, CRC64, XX hash 32, and XX hash 64. The XX hash family is actually seeded hash algorithms, and instead of limiting our implementation to the zero seed, I propose that we simply default to the zero seed and allow specifying the optional seed, because we've seen usability concerns with defaults in constructor or default parameters in constructors. I just proposed overloading the constructor to specify a seed, but then on all the static methods, it just becomes a trailing default parameter.
Is that because we already shipped the constructor, or
No, none of this is shipped.
so
This is just
why not have a default param on the constructor too?
so we could. We've simply seen that default parameters confuse novice C# developers with IntelliSense.
Okay.
So it's just a IntelliSense presentation.
But don't you think then it's kind of backwards that the one-stop shop statics are the ones that still have it, but then the more complicated case when you construct the objects, they don't have it?
I mean, I'm fine to collapse it. Uh, or we can, make proper overloads of all the statics, but that seems expensive because we can't hide that work.
Well, yeah, I think it depends on how you see this, but my expectation would have been that basically people who want to do hashing just do the static ones, right? So the simple case would be, I'm not sure simple is here the best way to say anything because none of this seems very simple, but like I assume it's like you just take the type, you call dot hash on it, you parse in the source array, and then you get back effectively a byte array, right? So it seems like if we only have one overload for the super simple case and everything else as well now makes sense of the optionals, I think that might be, assuming that you think most people would only want to do that.
Yeah, so I'm fine with saying overloads all around. That's it. I was gonna say
Well, that's
it's
what I'm saying.
expensive, but it's not
I
because
wouldn't
it's
say
not the
all
full
around.
pattern.
I would just say the simplest case has one that just takes the absolute minimum, and then the rest is just, one big method that takes like, 5, 6, 7, 8 optionals. I think is fine.
Right.
As
Well,
the
because
advanced case.
all that we have, right? This is the hash method that takes the input and produces the output, and then these next three are just the spanified versions of that. The span
Oh, I
input,
see
byte
now.
returning, the try, and the span to span. Certainly, the span to span should be able to understand a default parameter. Um, certainly.
Yeah.
But if you think that the friendly array to array wants to be an overload just for friendliness purposes, really the overload for the constructor was me trying to channel you with uh, usability emo. So whatever you think the right answer is, I'll believe it.
Yeah, I think Christoph's suggestion was basically like the most simple case, just make sure you have, basically a method or a parameter that takes less than 3 arguments. And then for the more complicated cases, you can just say we only have one that takes optionals. Because that's basically when people get started, that's what they're looking for. Right? They get scared when they see something pops up and it takes 12 arguments. I mean, I remember the first time I used Office VBA and like Word.open took like 12 arguments literally, and I was like, clear what to do. Right. I mean, otherwise, I think it makes sense. Yeah.
Okay, so is that the constructor gets a proper overload, and then the array in, array out gets a proper overload, and the rest are defaults?
Yeah, that's what we'd probably do.
Okay. All right. Resource limit APIs. 52079er.
Yep. Okay, so I think we can. So this is a new API, so it'll be exciting to essentially get a wider audience to take a look. So here in the issue in the issue proposal, I've kind of summarized essentially the key points from a more extensive design doc that I've linked at the top. And in that design doc, there's a lot more details with like the goals, the motivations, and some of the plans in terms of how we expect some of these implementations to work, as well as proof of concepts and those kind of things. But I think for just to start, I will kind of give a bit more of a brief overview of the background and motivation, and then kind of go over the APIs as currently proposed. And then we can get into, I expect that we'll get into a lot more discussion about specifics on this new API. So the background is that we want to provide a set of abstractions for defining rate limiting primitives or resource limiting primitives. And this is to kind of ensure that folks who want to do rate limits or concurrency limits will be able to speak the same set of languages and use the same abstractions for exchange types, as well as we will provide some default implementations that solve some of these concerns. The two main types of limits that we want to enforce or provide abstractions for are rate limits and concurrency limits. So rate limits is like I want to make sure that my APIs are only called with 5 requests per second, and any further processing beyond that, we are just going to essentially throttle those requests. Concurrency limits is more like uh, I'm only allowed to process 5 requests at a time. I may process more in a second if they end up being shorter processing like requests, or I may process less than that if all of these requests take a long time. And we wanted to provide a single abstraction that cover both of these cases because we find that in a lot of cases where this is being used, either in libraries or in other components, they want to essentially take in a limiter or an abstraction for a limiter and query for whether they can proceed with the operation, and they don't really want to know the complexity of whether it's a rate limit, whether it's a concurrency limit, or anything else. And to facilitate that, we do need to provide a explicit release semantic to essentially release resources back, especially in the concurrency case. And the default implementations we are thinking of including along with shipping these abstractions are 3 types of rate limits: fixed window, sliding window, and token bucket. And we want to also ship a concurrency limiter. And we essentially keep track of the resources acquired or obtained via a resource lease struct, and this essentially allows us to track ownership of the acquired resources. And for these limiters, essentially, we also want to have 2 separate types of APIs. One is essentially doing a fast check. Essentially, I want to obtain these resources if available and fail immediately and let me know if resources are not. And there's another essentially API to say, I want to acquire these resources and I'm willing to wait for them until they are available. So you've...
John, can I ask, do you want feedback as you go, or do you want to wait a little bit?
I think we should probably take a look at the APIs a little bit. And I'll just go over it briefly, and then I'll kind of open up the floor. And we can definitely go into essentially more details about these goals. And I can probably open up the design doc as needed to kind of elaborate on any of those points. But I think I probably want to go over the proposed APIs, at least the abstraction, really quickly. Okay, so essentially in the proposed API, we want to essentially create a new namespace, and it'll be a separate package. And it'll, currently we're thinking system threading resource limits, but that is up to the discussion. The key point is that we want to have this abstract class called resource limiter. And on it, we have 3 separate members. The estimated count, which provides essentially an estimated count of the resources available. This is mostly used for diagnostics, but in certain cases, it could be used for actually to make certain decisions. But we expect this to be mostly a diagnostics thing. For the acquire method, that is essentially the fast synchronous attempt to acquire resources. You give it a requested count to indicate how many resources you want to obtain, and you get a resource lease back, which indicates whether this acquisition was successful or not. And when it's successful, it also encapsulates the resource that is resource lease that is owned, and that is how you that is the struct that you interact with for essentially releasing back the resources when you're done. And then there's acquire async, which is a async version of acquire, which takes in a requested count as well as a cancellation token. And when resources are available, it'll return immediately. And when they are not, uh, it will wait until those resources are available before returning the resource lease.
John, did we rename acquire async to wait async? Did you make sure you synchronize the
I
versions?
did not synchronize this. Sorry, I did not synchronize this issue. It is in this other one. Sorry about that. Good
And
call.
all of these are public, I assume?
Yes. Yeah. And in terms of the resource lease, it is a struct, a read-only struct. It has a is acquired to indicate whether the acquisition was successful or not. A count that represents how many resources were obtained and is on the lease. It has a state. This is a bit more controversial one. So the intention here is to represent additional metadata such as retry afters, values, and error codes that certain limiters can return. And there are discussions on whether there should be an object with different interfaces or there should be a property bag. So this one, I think we need to discuss a little bit more. There are also two private fields that facilitate essentially the release semantics, which is a resource limiter reference and a action that indicates what what happens on disposition. So that's a very brief tour of the entire API, and I kind of want to start opening the discussion a little bit more to everyone before we kind of go further into detail for any of these. So yeah.
I have some behavioral questions.
Yes.
Feedback. So acquire, if I say acquire 5, that might return immediately with a count of 3, or it'll only ever return 5 or 0. I'm not clear on the semantics.
Right. So currently, the proposal in the implementations is that it is all or nothing. So there is no partial acquisition. But there is under alternative designs, essentially we have thought about essentially partial acquisitions as well as partial releases. And what that could look like is just we don't currently see any use cases for those, so we haven't added those yet.
And the
would that drastically change the API if we wanted to support partial releases from this?
So partial releases will entail additional functions on the struct. Essentially a release method that essentially you pass in an amount. And what that will do is it'll decrease decrement the count on the resource lease. So you can essentially release resources back to the limiter as you are done processing these.
So on that front, then, how does that interplay with resource lease being a read-only struct? It's backed by some unique object that's mutable?
Yeah, so that is potentially that'll make count I think a little bit more difficult, and it might entail using something on state,
This ties in with my previous comment about like what is the purpose of count at all if acquire and wait async only ever give you back 0, which is acquired equals false, or the actual amount you asked for. What is the situation where count is important?
So it is used by the ondisposed call or delegate when this resource is disposed.
Right, but that's an implementation detail for the provider of this resource limiter and resource lease. That's not for user consumption, right?
So the reason why we decided to have an explicit count that's public is we think this could be a very it could be useful for users to know essentially how many resources were obtained to kind of just keep track of it. But yeah, it is. I do see your point in that. Yeah, if we expect this to be all or nothing, then count is potentially redundant.
Yeah, I guess the concern is my concern. There's a small concern about redundancy. There's a larger concern about the immutability and copyability of resource lease, and what does that mean for count when it's disposed? If you have a copy made of it, like what does that show up? After you dispose, what does the copy show up as? If we did have partial release, what does that mean for copies of count? What does that imply for the underlying implementation? Blah 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 blah.
Like there's a comment that you have on dispose that says you can only call it once. That's generally not acceptable for dispose. Generally, you should be allowed to call it infinite times, and it only matters the first time.
How does that work with read only?
Doesn't.
You have to do special and complicated things.
Was it now read only? Or is there something else?
No, like if this, I mean, either it's a struct wrapping a class that is pooled or whatever, or it's a struct that holds an ID that is just a key into a dictionary that tracks the state, which basically it's the state needs to be held elsewhere, and this just manages calling into that state. Like that's basically the pattern for disposable structs.
Would it be better to make the struct not read only, but most of the fields other than count read only?
A mutable struct will be even worse.
Yeah, no.
But we use mutable structs for this kind of stuff all the time, don't we? Like GC has.
The problem with a mutable struct is if anyone passes this anywhere, now what happens? If you get a copy, what happens? And
Don't we have that that attribute that we didn't do yet?
we don't have move only structs yet. No. It'd be great if we did.
Just say,
but we don't.
Don't we have the attribute that we haven't done yet?
There was a bug filed. Like,
I
we
accepted
talked
that he
about
had a page in with the stream was in progress. I rolled with it.
We talked with the compiler people. The biggest problem with that kind of attribute is that Jared's concern is that it's very hard in Analyzer to get all the nuance right when the compiler makes defensive copies. So they don't want to do an Analyzer basically right now.
I see.
But I think the point still stands, right? Even if we had it, right? Imagine how annoying this will be.
Yeah.
So what else are we gonna do? What can we do here? Because the constructor doesn't take these state object, or you would have to have the state object store that information, right? That would be the only way with this design.
Right.
You'd have to do another allocation, right? You'd have
Exactly.
to have some sort of
Yeah.
object under the covers, which seems like it sucks. But if that's the
Yeah, that's what we were trying to avoid, but yeah, good.
Yeah, I mean, like,
Does the resource lease have to be a struct? I'm just gonna throw that out here.
So that was covered in, I think, one of the other alternative designs where we essentially make resource lease a class. And yes, it makes a lot of things simpler. You don't have to have a state because you can just subclass it. And we can keep track of like disposition. It's a lot easier, but the allocations on every successful like acquisition, either via acquire or wait async, was deemed to be too allocating for it to be a useful API.
I think it could be a class. I think we would just have to reckon with the pooling is all.
Yeah, you would just say.
And that bugs me a lot, but
once you dispose one of these things,
yeah,
you can't pool it yourself after you dispose it.
That's dangerous.
Yeah. We're back to the guidelines that we have for I dispose are dispose should be allowed to be called as many times as the computer is willing to run. That's basically because we've always had very loose ownership, and if you tie this in with some other
I
state, did
see.
it get both put in a using scope and tied in with somebody else's using scope, uh, or what? And so it's, yeah. I mean, that's the general stance we have. There are probably exceptions, but that's the starting point.
There's good rationale, which is that when you rely on only disposing once, you get into use after free issues. Now, the use after free issues may be manageable. Maybe we don't care about them. I suspect that we care about them to some extent, but they may not rise to like MSRC level. But you're certainly going to put a burden on customers. Some customers are definitely going to hit this, and yeah.
I mean, you can't even pool the state object then, if that's where you're going to store this information, for the same reasons.
Well, you kind of can, right? So basically, all you need to do is you need some sort of tag in the state object that you also burn into the struct. And then before the struct is allowed to use it, you have to check that it's the same tag, right? And so as soon as you return it to the pool, you would have some sort of interlocked operation that would basically bump that tag, right? So that next time the resource tag, if you copy the struct and somebody else now tries to access it, you know that they are no longer, it's no longer owned by the struct, right? It was returned to the pool.
Oh, we have a design for this actually in a bunch of places. The iValue task source has the same pattern where you pass in a version to a struct.
Yeah, basically.
Rough
Yeah.
it. Yeah, okay. I like that actually.
Yeah, the difficulty here is it seems like state is meant to be like a publicly castable thing, and like for it to be useful. So then,
Right.
if you're relying on state for storing this data, what do you cast state to?
Well,
So
I mean,
that-
a reasonable thing that I guess that I was thinking right now. We'll see if anyone else thinks it's reasonable. State doesn't have to be public on this thing. So if you take resource lease and it's just a struct wrapping some sort of state, whether it's a incrementing long or whatever, and it has to defer back to the implementation to provide answers, then like the state, you can say that the resource limiter type has, if they want to expose a state back to somebody, you have like, hey, give me the state for this lease, and they pass in the lease and you get back a state, and now it can be strongly typed. You get rid of object, you get rid of the casting, you get rid of the foofiness, the lifetime management. It's now a question that's tied to each individual thing, and you could only know what the state was if you knew what you were talking to, so let's just make it a static method on the thing. Or an instance method, or whatever.
But how do you make it non-public? Because the idea is that these APIs here live in the BCL, right? And then you have a high-level component like, let's say, Kestrel that exposes, let's say, the static helper, right? How would that access any additional data if this thing isn't public?
Well, if Kestrel's the thing providing it, then it's the thing that has the state. Like if Kestrel writes a resource limiter, then they own the state.
Yeah.
It's their static method.
Sure, but they would have to somehow associate it with their lease, right?
Right, and
So
that's
do they now have a
the
dictionary from whatever to whatever.
right. Again, that's
I mean,
back to Steve's comment of basically make it look like iValue task source. It,
And I
it
see in the
it's a long.
comments meeting chat that's what Stefan and David been thinking as well. So I can take a look at that pattern and kind of update the API afterwards. I'm not that familiar with it other than what has just been discussed.
I think that only solves the double dispose thing, right? I think we're saying like the design is the same, or maybe we need two state objects. One that's used to round trip state from the call to the constructor to dispose, and then one that's actually for the user.
I think if I understood correctly, I think Jeremy's suggestion, it was the state is basically an opaque object that's purely used for the implementer of the derived instances. And then
Yes.
that provides some other API that uses that state to produce the thing that the developer would actually consume.
But the issue is how do you write a general consumer that reads these states from
Well,
What are these states? Like right now, there's, I mean, just as what's on the screen, there is no general consumer. I have no idea what this
Right.
means.
The two of
Yeah.
them that are potential are the retry after and the error code.
What is retry after, and what is the type of error code?
Retry after is you didn't get this resource.
No, no.
Don't try.
What is the type, and what am I casting to?
yeah.
I
Like
mean,
so-
yeah, that's
this says it's nullable object.
and I have- well, right?
Right.
Yeah.
And essentially we kept that mostly to be as flexible as the implementer of a resource limiter wants, but essentially those implementers will need to. So one of the proposals where this is, we keep it as an object, nullable, is that the implementer of the resource limiter will also ship a set of interfaces. For example, I retry after is supported or something like that. That actually indicates is that interface will have like a getter for example, retry after, and it might return an int or something like that. And then as a consumer of the resource limiter implementation, they will need to know about those interfaces and try to cast these objects to those interfaces before accessing the value.
I mean,
That doesn't solve the general consumer either. Like if ASP.NET's middleware wanted to put the retry after header in, how would they do it? Given that I could write my own resource limiter.
Yeah, so the alternative to this interface kind of approach is to have a property bag instead for the state, which I think the current proposals I read only dictionary of let's say string to object, and essentially having a set of like well-known essentially header values or like essentially keys for like retry after and stuff like that.
It seems like the other alternative here is just to bake a notion of retry after into the core abstraction, right? I mean, it feels like going super general here and trying to enable every possible thing we could under the sun. It seems to me that a rate limiter at the end of the day isn't that fucking complicated, and there's just a small set of cases you want to handle and a small set of information you want to provide. Let's just define an abstraction, and there's like 3 ways you want to do it, right? You said fixed window, sliding window, I don't know what they are, but there's like 3 implementations of the abstraction. Let's just define an abstraction that works for those 3, exposes whatever information you need out of there, like retry after or specific status codes or whatever, and call it done.
The issue with that is that the teams in Azure actually want to provide more information via configuration that is arbitrary. So we can maybe turn that into a string, like other stuff, or some property bag or something like that. But they
want to do what? But I don't understand. They want to provide more information to who?
The consumer. The default implementation in the BCL will be in memory. The ones in Azure will like use distributed caches to get counts and have configuration based state. And so when retries fail, they're trying to communicate to the caller why it failed. And there are a bunch of strange reasons that it may fail, and they want that to be exposed to users.
But the caller is still Azure, right? Like this is their...
No. So the caller is people that consume. There's a producer and a consumer, and one developer is like coding against the actual abstraction, and the infra engineer is config to say if this fails because you went over some limit, the error is this. And that's in the config file somewhere. And the config file is read by the rate limiter implementation, and it will surface those errors whenever things happen. And the config values change on the fly depending on like who knows what.
Right, but the thing reading the state is still the Azure service. It's not that this is a third party walking up trying to do something and they're expected to understand what this object state is in order to understand what HTTP response code they're supposed to give back.
It could be the middleware in ASP.NET Core that the Azure rate limiter implementation swapped out. So ASP.NET Core is suddenly surfacing more information because we have this property bag if it was generic.
Right, but
For
the thing
example.
consuming the state was still written by the person who wrote, or written by the same concept as who wrote the rate limiter implementation that's using it.
No, it doesn't have to be. It depends, right? Like, so like John is going to write the asynchronous core middleware that will use the abstraction, and then the Azure team will write a different implementation that surfaces more information when things fail. And they're two different parties that the person consuming and authoring the rate limiter is different from the person who's actually consuming it in code, which is ASP.NET. And maybe that information they want to surface somehow.
Okay, so then we're back to the
is
question
that
of how's that middleware supposed to understand what part of the state is relevant?
Exactly. Yeah. Exactly. Yep. And the
so?
property bag.
But isn't the expectation it's kind of like headers where basically the Azure
Yes.
team who does that they would document here's additional
Yes.
keys
Exactly.
that you may want to check for, and then somebody else can write that code if they wanted to.
Yes. Exactly. And I guess our code would basically give you a hook if things fail, so you can actually get access to the state bag that lets you like cast or whatever. And we could say like you only get a string. You get a string or an object or an int or something like that. I don't know, but
So the thing I still don't understand. So why? So you said key value pairs would be preferable because they're like you could have a semi-standardized set for those. But like, isn't the idea that if I am Azure, I have some sort of state I want to expose, like a single type would also work, right? It's just that it's unfortunate that if you have a type, then you need to put the type somewhere. Now the problem becomes, well, how do I consume the Azure thing without depending on that? But presumably if the Azure guys have a resource limiter implementation, then the consumer of said resource limiter by definition somehow has a reference to those APIs, no? Does it really have to be decoupled?
So the reason it's decoupled is because the person consuming the API, ASP.NET, does not have any idea what the Azure implementation actually is. So the question becomes, we can't surface it by default to the user, but the user can basically, I guess, downcast or get the keys.
They have to essentially try a bunch of things that.
Yeah. So is the idea then there are some conventions that a framework like ASP.NET could look for?
Right.
So basically, there's a certain key that says retry after or whatever, and then you say, okay, the value has to be a time span or something, and then you extract that key and then do something useful with that.
Yeah.
Because then, I mean, the problem with these kind of designs is also that sounds great, but then you really have to be very careful how you design that, right? I think for HTTP that sort of works because there's a very strict spec for what headers are there, right? But like. If you have this open-ended key, I mean, the other problem with key value pairs is that they're fairly expensive, right? If you're concerned about allocations, then the key value bag is not going to make your life any better, right?
Right. So in the case of essentially where you want to expose more state back to the user, we're kind of okay with allocations there. It's more like for very, I guess, the default implementations that we ship, we don't want to have to allocate state.
Yeah, I mean, I will agree with
it failed, right? Like only failed requester is going to have this extra information typically.
Let's see. So I want to say in most scenarios that's true, but we don't want to preclude or prevent the ability for you to surface something when things pass either.
I mean, the state is on the lease, right? So at this point, you don't know yet whether it succeeded or not.
Right. Essentially, even for successful ones, we don't want to prevent them from being able to return state. Although, yes, state is usually most useful after a failed one.
Yeah. So, because I on the screen, I get to doodle. Like, if we think that you're always going to need to know what the rich type is in order to get information, it seems like just put it on whatever the rate limiter type is. So if the middleware has the on failed acquire, then and it passes the resource lease back into it, then they can now call get metadata, which is their own API that returns whatever rich type they want or loose type they want or whatever. The resource lease doesn't need to know about state. It just needs to know what's its ID. And that's now the key into their their big bucket of stuffs.
So the only problem now is imagine that my rate limiter is really, it says Azure rate limiter, right?
Yep.
That now means, now imagine you write ASP.NET, right? So ASP.NET doesn't want transitively to depend on some proprietary Azure API, right? So your model works well, basically, if you think of the limiters as leaf nodes in the system, right? Somebody defines them, and then the consumer, the ultimate consumer, the customer, they can reference the framework components in the leaves directly, right? But the problem is that doesn't work for anything in the middle, because now you have this problem that everything in the middle who wants to react to that
Well, but
somehow has to get access to those types.
But
right?
the only thing that was said so far, and maybe I misunderstood David, is the only way that this would work is if the middleware exposes the callback so that Azure even knew what to do with their state to know how to react and log and inject headers and etc. Once you have a callback, they now it's back to this is just a key into some other dictionary. So the middleware never looks at the state.
Right,
It just
but
gives the whole resource lease back to somebody else.
That's correct, but the scenario where you want to infer like a header based on the result of that state object, and so basically, if there's any scenario where ASP.NET needs to read the results, is where you kind of need the more abstract thing that isn't the concrete type.
Right, and then that once we're there, then it feels like if we do the property bag, we're at the standard problems with property bags, which is weak typing, and at strong typing we can't agree what goes there, and object feels like it's the worst of all worlds.
Yeah, I mean, I would say like it would help if we could actually take some of these Azure concepts and actually design it with concrete terms rather than trying to solve it in the abstract. Because the thing is, what concerns me here is, I mean, David said this in one of those other meetings, is that he basically turned this into Owen, where everything is a dictionary to a func, to a dictionary of a func, and then you have these relatively convoluted signatures where it's not clear what the heck is going on. And then the problem then becomes, you think it's very generic, but when you actually then try to use it, then very often you find it's not expressive enough. And then you're stuck with this super complicated but not quite useful API. So I feel like I agree with Jeffrey. Like, if we look at the actual scenarios you mentioned so far, they seem relatively easy to solve with just ordinary APIs. But if you have very specific Azure things where you say, okay, here's this open-ended grab back of state, then I think it might be worthwhile to actually design what that would look like, both in terms of how the Azure SDK, how the Azure guys would derive from resource limiter, what they would expose, and then also what, let's say, ASP.NET middleware would read out of that. Because I mean, you can also imagine a world where it's just, certain things just you can't do, and it's okay. The problem is if you try to make everything possible, then you really end up with, object or key value bags of arbitrary keys to arbitrary values, which, again, like, I'm not convinced you get away with that. Like, I mean, we have seen this in other places like VS, for example, where we have math components of arbitrary metadata. And very often, like, there's only one combination of stuff that works. And so as soon as you have something else, it just all collapses, and then you get weird runtime errors because nothing composes anymore. And then you go hunt for, like, okay, who fucked up, right? Oh shit, this was a nullable time span, not a time span. And now the cast failed, and like bad things happen, right? And that's kind of the concern I have when somebody says key value pair or, object, right?
I will say that the feature collection concept from ASP.NET Core is pretty good for this, but I wouldn't want to use it here, to be honest. Unless we had a good scenario for it.
Collection is you have multiple middlewares and so forth that might want to set features, right? Here
Exactly.
you just have
It's more useful.
a limiter. Yeah.
Exactly. Yeah.
I think it generally, I think it works well if you have, effectively like some sort of spec for what the keys and the values are, right? As soon as you have this super open-ended thing, like, it doesn't quite work. That's why I think HTTP headers work really well, because you have effectively an official, here is what you can put there kind of authority, right? And then there's, this particular API author added these things, but there's a whole industry around that, right? So like it's not like completely arbitrary, right? I mean, it is arbitrary, but with very strong expectations of what arbitrary means. And so unless you establish that here, it's going to be a mess. You will have, somebody calls it on retry after, the other guy calls it, retry after delay or something, and then you would have to basically babysit the definitions of those keys very aggressively.
Right. But would kind of I guess naming it as like a set of header values, is that too limiting in terms of having these? Like, I think that's like just a trade-off between how prescriptive we are and how flexible we can be, right? Like, and then we just
I mean,
kind of need to decide where that
if you
goes.
go, I think if you go down, let's say key value pairs, what I would encourage you to do is just define a framework type that is what we call a strongly typed string, basically, where you have like a quasi enum, but the members are strings, kind of like HTTP headers work. And then you can say, here we put like a bunch of things we know people want to use. I mean, retry and whatever else you have. And then, but you can also always construct your own string, right? So it's not like an enum that is literally closed for everybody to extend. But then because you have this base type in the VCL, you kind of make a very strong statement about, here's already 20 strings that we standardize. So if your shit is one of those 20, pick one of those 20 things. Don't come up with your own naming for that, right? And given that it's just strings, like nothing prevents us from literally adding everything to it because it's basically free. You're not extending your API closure, but you make it so that similar to headers, like there's this catalog of well-known names, right? And you try to keep that the master list.
Yeah. Hash algorithm name is an example of strongly typed string. It looks like an enum, but it's actually just a string.
Yeah.
Okay. That is definitely something we can look into. I think that makes sense.
And then ideally, the documentation of the key would also say, if this key is used, the expected value is of this type or something, right?
Right. So essentially, let me just make sure I understood it correctly. It's essentially saying in the property bag case, we essentially have the keys, or like the keys be these kind of strings where it's a more well curated list.
Yeah, exactly. So it's curated, and you're trying to be, basically you use that as a way to force consistency, or like to get to a world where people are consistent. I think the trick will always be that, and I think this is why I think it will be useful to actually go through a concrete exercise of saying, here is the Azure scenario, here are the 6 or 7 things I want to expose, and then just sketch an API what that would look like. Just looking at the abstraction, I think, is a bit hard, because it would be useful to see, okay, here are the 3 parties involved, and here's what they can access. Here's how they would actually, get the state. Here's how would they reason about the state, and here's who is, strongly typed, tied to whom, basically, right? So the framework case earlier we said, okay, the framework case can't access the Azure API, so they just access it through the key value bag, for example, right? That I think would help the API design, because otherwise it's a bit, we're in the weeds, and it's kind of hard to understand why things have to be weakly typed when they're really just, some type.
Yeah. So just a brief kind of like a summary of like the things that they generally include in there. The reason why here I called out retry after and error codes are because those are pretty specific, or like those are pretty common to the different limits that they implement. But depending on the types of like rate limits or concurrency limits that they configure, these can be very arbitrary values for specific limiter implementations, which is why I didn't include the full list, because they are like, only used in 1 or 2 places, and there's just a huge list. But yeah, I can get some more details on what those values are, what essentially to get a flavor of what those kind of extensions could be. But I agree that essentially if we have a curated list for the common ones, and then essentially allow that to be a bit more extensible for arbitrary values, I think that is a good compromise.
Yeah, sorry, the goal wasn't complete in that. The goal was just to sketch effectively how these 3 parties would, exchange information, to just get a sense for what flavor of information would be in there, and what shape it would have, and how the consumption and production feels like, right?
Okay, yeah, I can totally get some more essentially samples for what this scenario looks like. Yeah, sounds good.
And then the other one is kind of like that, kind of is more probably between you and David. Is like, just what's the cost, right? Like, what's the allocation cost, and do we think that's viable for the kind of resources you want to protect, right? David in one of those meetings mentioned that they want to do it for individual reads and writes of buffers. I mean, once you're down to that level, yeah, you don't want to allocate a dictionary every single time you read, like, 4K, right?
Exactly.
And so I think that's kind of the other thing. Like, I don't know, like, my understanding of the resource list was kind of the more coarse-grained access to a service thing. But if you really go down to the individual reads and writes, I mean, if you want to use that API for that, then it needs to be super, super lightweight.
Yeah, hopefully in those cases, the limiters you do end up choosing don't allocate state.
Yeah, it just means if you're talking about that, low level like ETW and Windows kind of thing, like there's not much information you can put in those things at that point, right? It needs to be super, super cheap.
Right.
Yeah. So John, like the thing about state that's I think I'm still not fully there for yet. Like, I think either it needs to represent the thing returned to the customer or the thing that's round tripped to the on dispose call, and not both.
I see.
Like, do we have two states or do we have one thing?
Yeah, I mean, if we change the resource lease to just be a long, basically, then the on dispose call would just get the long, and
Right.
whatever state it's supposed to free at the same time, just that's part of however the limiter handled its release lease code.
So in theory, this thing needs a version argument to it, right? Like, when you call it yeah.
Oh, sorry. What do you mean by version? Like, does
So you pass in the state, the count is acquired, the limiter, and a version. So like to prevent the misuse around dispose.
and the version, like, is that like a I guess API version, or like what is the version represent?
Like, my notes here, I called it lease ID. It's just a long that is incremented.
Oh, okay.
So lease. I mean,
Look at
either start at
how,
0 or pick a random number for your start,
Yep.
and like you've produced that one. The next one gets this one. The next one gets this one, and then that basically just lets you key into a dictionary that is the constantly maintained dictionary, and you end up with eventual stop allocating state.
Yeah. A long or an int?
Personally, I recommend long because that's extraordinarily unlikely to cycle back around.
I think we use a short in value task.
Which is why value task is one of the most dangerous types in the framework.
Yeah, when we do that, basically we had some extra state and we decided to use a little bit of it to help make it a little bit less likely when you misused it that you wouldn't be notified, but it's not perfect.
I see.
Do we care about torn state here? Like, basically, do we care about how big the struct is, so when you assign it, you don't get partial?
I mean, if it needs a callback to the limiter for the dispose, then it's bigger than a register already.
Yeah, I think the key here is you shouldn't misuse it, and if you do, we just need to make sure that you don't break the system. You can get into various kinds of exceptions, but you shouldn't have type safety issues, which means the implementation of these things should not use unsafe as an optimization when trying to cast these things to whatever.
Right. So you're basically saying, like, if you just get a partial, like a torn state, when you basically have part of the fields written, but then you just get the wrong callback or the wrong version, but nothing bad really happened.
Right. You might get an exception. You might, call the wrong thing because you just as if the user had any other kind of bug, but you wouldn't get an access violation. You wouldn't write over, your memory to your you wouldn't treat one type as a different type.
Right.
Mm-hmm.
I mean, crashing is a form of resource limiting, right?
Fail fast certainly limits all resources.
Maybe we should ship that in the box. Fail fast resource limiter.
You get to use one per process, right?
So, David, I kind of wanted to bring back another point, which is essentially kind of the idea of splitting out a round-tripping state versus a state that is used for dispose. Most of the samples of what goes on the state I've seen so far are literally the information that goes to the user. The only thing that is really the only state that is kind of passed into the on dispose is the count. I kind of would lean towards essentially not having a separate kind of state for on dispose, because I don't see what else could be needed than the count. Like I don't see a value of being flexible there.
Well, why don't you just pass the whole lease back?
Sorry?
Just pass the whole lease back.
That's possible, but it's not clear to me that that is completely necessary. So, essentially the action the on disposed delegate could take essentially the resource lease, and we just pass this in. But I think just the resource limiter and even and the count should be sufficient. Additional.
If you're
the ID, right?
Yeah, if you're going to make dispose be idempotent, then you need the resource limiter and the lease ID. If you think that as an implementation acceleration, some implementations may not want to actually save the lease ID, which means that their dispose isn't actually idempotent, then accessing the count or state or whatever else off the resource lease would work. And then if you added another API in the future, everything should be able to be tied back to the lease. So you either get resource limiter and long, or whatever your ID type is, or resource limiter and resource lease, and now everything else is just quibbling, and they get to read whatever properties they want.
Right.
Trying to expand it to be like, this is a combination of an int and a maybe object is weird. There were some comments from YouTube chat asking about the allocation of state and doing the, like, depending on how you want to wire things up with, maybe there's a get state delegate that you pass in where if nobody wants the state, it maybe doesn't even allocate it, but it probably would have to, because it would need to know it ahead of time of.
Yeah.
So never mind on that.
I feel like state is a misnomer. For me, state feels like the thing being a round trip from the limiter to on dispose, versus like a result, the thing being passed to consumers. Like what happened because I called acquired and I got a result back.
Yeah. So I mean, I guess an interesting thing is if most resource limiters are expected to produce state, and they're expected to produce distinct state for every lease, then really the lease should just be a class.
Right. Exactly.
That says it's idisposable, and it's abstract, and they have to write their dispose semantics, and now you've solved all your problems.
Right. So the thing that made it not be a class was we want to be able to basically wrap a semaphore slim without allocating. So dispose calls release.
Right. Essentially, dispose is the release semantic for the resource, and the reason we wanted that is to essentially indicate ownership of the resources that were acquired, unlike semaphore, which you can release without ever acquiring anything.
Yeah. No. This is just while that's an interesting goal, so that one wouldn't be producing state. Is that going to be the exception or the rule, right? And so it's if if almost everything's always going to produce state, then it seems like resource lease should just be a class. Or you can do the complicated, long tracking an object lifetime from a dictionary somewhere, which is doable. But
sorry, I don't understand. Like, why are you saying it doesn't produce state? I mean, the state is the semaphore, right?
I think it's that the semaphore existed. You call acquire, it returns a lease that says you acquired it. When you call dispose, it calls release, but then needs to track somewhere that says it's already called dispose for
Right.
lease number 17, so that if it gets called a second time, it doesn't call release on the semaphore a second time. Because now you're mixing the semaphores, I'm a hard API to use me correctly, with I'm disposable and I can be disposed multiple times. User friendliness.
Right.
Yeah, I kind of assumed that the instance, like the state field, would now point to the semaphore. And yeah, I don't know how you track that you already disposed it. I guess you null it out, but I don't know how you do this from the callback.
You can't, because it's a read-only
Yeah.
struct.
Yeah. Yeah, I don't know that.
Can't or shouldn't. Kidding. Can't.
Well, double dispose needs to work, otherwise you have really bad bugs.
Okay.
I'm
You
telling
wanna-
you, embrace the mutable struct here.
But I don't see how that changes, that solves the problem that you can call dispose multiple times in a linear flow, but it doesn't solve the problem if it gets copied by value.
Right.
I don't know the usage semantics of this thing. You wouldn't pass it around. I mean, I don't want to say never, because like people do stuff all the time. But the usage pattern is basically, await using, or var using, acquire, or acquire async, and then that is the end of it, right?
I mean, be careful, right? Because
I
people
know.
extract method all the time, right? And I think the problem is, like, people really do this a lot. I've seen this all over the place. For logging and other reasons, they just put it behind a callback, and then
Yep.
boom, the compiler made a copy for you, helpfully.
Yeah. Okay.
I mean,
I don't see how this is more
Yeah.
dangerous than either memory handle or value task. I mean, your potential of doing terrible things with both of those are tremendously huge. In the scale of potential badness, this seems much lower than those, and they are mutable structs.
Yeah. What does GC handle do? Now I'm wondering. Does it? I don't know what it does.
Would this
I
be
mean, the
used?
problem.
Would this be called directly by users, or are we expecting like an HTTP client message handler, something that uses this behind the scenes for API calls, things like that?
Yes.
That's a good question, and the answer is both.
Answer is yes.
Because if we're expecting every web developer to want to wrap their API calls with this, then I think it should be fairly foolproof.
ASP.NET Core will have a thing that does it, that you don't have to call the APIs directly, but we do think people will want to call it at some point.
Yeah. Essentially, we want it to be flexible enough that if the developer wants to essentially limit the amount of processing in a particular section of code, they could use this.
GC handle is a mutable struct. I had no idea. I mean, I guess it makes sense. I never thought about it.
It basically has two states, right? I'm looking at the code right now. Yeah, valid and invalid, kind of like safe handle, but a struct.
Interesting. So there is prior art. Makes me feel less awful.
I mean,
About using a mutable struct.
it just, like, if you're aiming for the usability of GC handle, then okay, but it feels, like Corey's point, it feels like you're trying for something that's usable, and once it's easily usable, then it kind of, we're .NET, so it should hold your hand.
Yeah.
Yeah, GC handle's not disposable, I guess, right? It's got free. But
Ooh, that's different.
Safe-ish. But
I do agree with what Jeremy's saying. There's a trade-off here, right? I guess the place I get stuck a little bit is where we say we don't want to make the trade-off. We want it to be, safe and fast. It's like, well, pick one and optimize for it.
I am worried that like if we do the allocation per call, it'll basically eliminate this thing for a bunch of scenarios. But maybe
Right, and that's why my question was just if the let's say it's the you're like Azure will say it's too allocatey, but if Azure's allocating whatever the state object is for every call to acquire,
Yeah.
then that's the same as allocating the resource lease. We're just
Right,
changing where they have
exactly.
to do the allocation. If the Semaphore Slim thing is actually expected to be a majority use case, then now the complexities here start becoming more warranted. But
Right.
what I've heard suggests that resource lease should just be a class, and that solves a lot of problems. But I don't know what the balance is between the Semaphore Slim case and the I have a giant collection of diagnostic headers.
The thing we're hitting here is that we're basically trying to design the API to support both high level and low level consumers, and the trade-offs being made are different between those two things. And it's fine in general, but I guess the question is like, in the Azure case, I think that is the case where they would allocate the most, and it would be fine. For the case where you're like doing socket reads, is where it kind of like we would have to have a different API than this, if that was the case. The thing is, it would look very similar, but just have a few hard to use things like the struct, for example, versus the class. But maybe they're two different APIs, but that feels, I don't know, like it breaks the abstraction.
Acquire Slim.
I know. and the fact that if we made it a class, that pooling would make it hard to use also worries me. Like,
well, I mean, with a class, you can't pool it because then you have use after free with dispose.
Right.
I mean, you can do complex pooling with the what's that thing we do in array pool? The callback of the GCs running, and you wake it up off of but that's that's frightening.
Yeah.
I mean, you could have like literally like resource leads and value resource leads, right? Or I mean,
yeah, okay.
I think the kind of takeaway I think is you should design the API like with concretes, right? And then see how far you get, right? Design the API you want, and then see when it actually falls apart, right?
So
like it seems also problematic to optimize this for this high throughput scenario, but then in practice, many people have to use the API, and it's mostly high level work, and now you have this super low level design that nobody can reason about, right?
Yeah,
that would also be bad.
We actually have prior art that this API replaces it in ASP.NET Core today, right? So it's not coming from nowhere. We actually designed the current API to not allocate when you are concurrency limited today, and it doesn't allocate unless you end up queuing, and we want to preserve that behavior and not just allocate because you're acquiring a lease. So
what is the API?
I'm guessing you don't have state then?
No.
We don't, because in ASP.NET Core we just had a more restricted set of API surface essentially. So state is essentially new to this, which makes it tricky.
But the usage was a bit harder, right? It was more like a acquire release semantic than the disposable pattern.
Right.
It feels weird to me, but just brainstorming. What if we flip it to make this more of a kind of like the DB connection classes, where you can do like create lease, and then the lease is what you acquire in free. So instead of caching stuff inside of the resource limiter, the user could cache it and reuse the lease as much as they want.
So essentially the user creates a lease and then do lease.acquire?
Yeah. That would let you have all that state and avoid the allocation every time if the user deems that important to themselves.
So the idea is that the consumer then is basically responsible for pooling their own leases if the leases are expensive?
Yeah.
That seems reasonable. My brain is malfunctioning.
But
How-
yeah, how are you supposed to know what kind of
How
lease
does
to
that?
build?
Yeah. Yeah. Exactly.
Like, I think the current design is supposed to allow for ASP.NET Core has a notion of you can be a concurrency limited API and you get to via the configure method or whatever say and use a fixed window 5 requests per minute
Yes.
limiter.
Mm-hmm.
So if you have to build the lease yourself, then that feels like now you're back to needing the lease factory, which is what the limiter is.
Yes.
Yeah, it also seems like the control is going the other way now, right? I mean, if your goal is really to say at any given point in time, I have no more than n number of these resources or n number of resources per given time period, then if people are responsible for pooling the resource leases themselves, then you can no longer guarantee that. Now you have distributed your resources, which was
Well,
kind of the point of not doing in the first place.
I think we would call it something other than lease in this case, but I think the idea is you'd have any number of leases, and when you call acquire on it, that's when it actually takes the lease. So it would have the same sort of limiting semantics that you have right now.
Right. I don't
I
see it
see.
as fundamentally different, other than where you allocate.
Corey, can you sketch that?
Yep.
And paste it in the chat. That would be helpful to see it.
I think I understand.
Yeah,
Now.
I
You're
mean,
basically saying
the
that.
names of things for
Yeah.
sure. Sorry.
So you're basically saying the acquire call on the lease might blow up, and that's something you would have to kind of handle then. But that means the resource lease can be a fairly expensive object because the object itself is basically not representing that the lease already happened. It just represents the metadata for a lease,
Yeah.
and the lease may or may not happen. And this way you can effectively pay for the cost by
Right.
pooling those guys.
It's
And
both
then
the
other
request and the
question
state.
is, like, I mean, if you went that route, would the request count be mutable on the new lease objects if you wanted to pull it and that's changing? But yeah, I mean, there's true things there.
So while we're doodling with that, estimated count. Personally, I feel that this is lacking in a name because estimated count of what?
Right.
The total things that have ever been acquired, the things that are available for acquired, the what other interpretations did I write down? The number that are currently consumed. I think that it needs another either a noun or adjective. Language analysis is failing me here. It needs to say what it is. So,
Yeah.
estimated availability.
If we're, yeah, I agree. If we're getting into naming, I've got all sorts of feedback. But you want to do that?
Yeah, throw it out.
No, I feel like we're sort of, I don't know where we are here. Are we saying, it feels like we're kind of saying, okay, we have some more things to explore before we really get to the point where we're ready to approve this. So what more do we want to do here versus going off and bringing it back another time?
We can definitely do a little bit of the naming, even if we expect some things to change.
No, that seems reasonable. You're right. So on that note, the term resource limits is super general, right? Resource limits,
Right.
when you say resource limits, that could mean anything. It could mean CPU limits. It could mean memory limits. It could mean bandwidth limits. It could mean resource limits is something that's applied to a whole lot of things. I would try to find something more specific than that. Whether if it's really about rate limiting, then maybe you call it rate limits or rate limiters, or maybe there's something else. But the term resource limits, I don't think gives a very good idea of what this thing is about.
Right. So I'm glad you mentioned it because we kind of did want this to be as general as to essentially cover both rate limits, concurrency limits, and potentially limiting based on amount of free memory you have, or some other metric like ambient metric that is not essentially controlled by the user. Like you can theoretically write an implementation that is based on arbitrary, like I guess environment.
Well, but I mean, if you're doing memory limiting, which is really the OS's job, but if you're trying to do some soft memory limiting, that's really just a rate limiter where your count represents expected megabytes or terabytes or whatever you feel like allocating. And that's a user conceptual model on top of the same rate limiter, because what you're trying to limit is how much concurrent memory can be allocated. Things like CPU, you can't say I would like to acquire 10% CPU, because like you can't. And if you're saying I would like to acquire 1/10 of the processing power of this application, then
Right.
again, now you're down to your resource that you're acquiring off of concurrency is tenths of a CPU load.
Right,
And so
and that doesn't make sense. It's more like in those cases, let's say you're basing it off of CPU usage. Essentially, the resource limiter will pretty much ignore the requested count that you give in and say, oh, like right now the CPU load is, let's say, under 50%. You're allowed to proceed. But if the CPU load is above 50%, then acquires are going to fail, and wait asyncs are going to essentially wait. And then, so that is a possible implementation. Not saying that's the right way to do things, but that is a possible use case.
The thing is, I do think that this is supposed to be super abstract and not actually be rate limit specifically. Like the impetus of this overall API was a combination of talking to the team in Azure, but also because there was a second team in Azure that was trying to bandwidth limit a bunch of reads on WebSockets. And the pattern is the exact same thing. So we basically looked at a bunch of rate limiters, concurrency limiters, and ones doing other kinds of limiting. And we tried to actually create a concept that encapsulated all those things. And it turns out it does boil down to these like fundamental operations. So it actually is supposed to be super abstract, and you should be able to write a thing to restrict or to limit an arbitrary resource given this shape, I think.
Okay, since Jeff didn't start talking yet. Same random timeout. So how are you supposed to represent like a bandwidth limit with this structure? It feels like what you're saying is I would like to acquire some peak bandwidth availability, which is back to just its concurrency on what the theoretical available pipe is, because bandwidth is really a measure of now, and this operation could last a lot longer than now.
They basically were tracking how much bytes were being consumed by one single pipe, and they had a bunch of overall bandwidth. So they said that I'm basically not going to let one of these sockets starve the overall throughput. So if this socket read too many bytes, I'm going to throttle it until someone else can grab other bytes. So like I have 100 bytes and the socket is hogging that bandwidth. I'm gonna throttle this one socket because it's eating all the bytes. I'm gonna let someone else consume that overall thing. So they were trying to basically not have one socket starve the overall system and to balance out the load across the end sockets, and they were doing it by injecting delays into reads and writes.
Yeah, so is the nice socket send supposed to just call acquire with the byte count? Because again, if so, yes, you're back to just it's a concurrency limiter of what your total available thing is.
But that's why so even though it was a concurrency limit, the thing that they were trying to implement was a bandwidth limit, and the abstraction still held, because that is this pattern is the common pattern for trying to limit any arbitrary resource. As long as you can kind of model it into those patterns where you call acquire passing an account, it can be made to match like any resource.
Right, but it's still a rate limit,
Right.
whether you're measuring it as bandwidths data per second or you measure it as what it sounds like here, which is actually kind of data per second per second.
Yeah.
But it's still a rate limit, and so it's not generic resource. It's not. Yeah.
Yeah, I mean, so two things. I think first
Time
of all,
concurrency.
if we want to talk high level naming, let's talk about the high level naming and then maybe go in detail from there. But so it's not threading, right? So like that's where I would start, right? If you want to put it somewhere, I think Lisa did a pass over the namespaces. The best I can think of is something in runtime, right? System.runtime dot, let's say limiting or rate limiting or something. That makes more sense to me than threading resource limits. The problem that Jeremy brought up last time, which I agree with, the word resource is really very unfortunate because the thing is, it has such a strong bias in .NET towards embedded resources because we have a resources namespace and that's all what this is for. So even if you call resource limiting, it's kind of, I still think people will be confused when you say that. So I think, honestly, like even if you say like there's other things that aren't rates, I think going with rate limiting is probably the better phrase because people think of what you do here as a form of rate limiting, right? And I think, so taking that as the high level concept and then saying, yes, you can maybe model slightly more than rate limiting, I think is still better than trying to come up with the most generic and most abstract term because then you probably have the least desirable API, right? People really like nouns, they know what they mean, right? So if you can make the thing kind of specific, and I mean, I'm not saying resource lease or resource limiter aren't, but like the problem really is I see them and I'm, as a .NET guy, kind of confused of what that means, right?
Yeah, I agree with that. And just on the term resource, even if I ignore the classic C# notion of resource, the term resource is so overloaded to mean a bunch of different other things that
Right.
using it conveys, even if I get past the fact that, oh, wait, this isn't like C# resources, I still wouldn't quite know what to associate it as being.
Yeah. Because obviously it's the thing that you get when you resolve your universal resource locator, whatever URL actually stands for. The R is definitely resource.
Right. So kind of just adding a little bit to the naming discussion. We also, so I agree, and resource is very abstract and overloaded, and yeah, we do see some issues with that, but essentially we're trying to also spark some conversation here on what other possibilities there could be. So other things we have thought of previously instead of resource limiter are like throttler. A rate limiter, it was also kind of proposed. And in that case, we need to essentially, instead of differentiate between rate limits and concurrency limits, we can call it like concurrency-based rate limits or time-based rate limits or something like that. So that is definitely possible. Throttler being another one. Yeah, we probably don't want to just call it a limiter by itself, like too short of a name. Also very kind of arbitrary as well. So yeah, any thoughts about those other possibilities?
I mean, if you call the base type rate limiter and then you have, I mean, presumably people don't talk to the base class. Usually they talk to something more derived, right? So because it's kind of specific to, yeah, basically the actual thing you want to do kind of thing, right? And at this point, you already give it the name that makes sense, right?
So it depends on who you mean by the user. Like as a middleware, for example, we will only work with like essentially resource limiters or rate limiters. We don't know the specific like implementation type.
But then you also don't care whether it's concurrency or non-concurrency, right?
Correct. Yeah.
Question. So rate implies per something. Per time.
Right.
Like, is that an issue? That it implies that? I think like throttler is better, but it also like.
So I would say pick a name that is 80% correct and ignore the 20% where it's not. The only thing where that may be unfortunate is if you need to introduce the concept of a rate limiter as a dedicated abstraction with a different API shape, because then you don't want to pick names where the things are too close to each other. But assuming it's just a semantic thing, where it's like, well, it says rate, but it's really not. Then I don't think it matters. I think it's really where it starts to hurt your abstraction is if you need two dedicated concepts, then you need to make sure that those names have names that the user can easily separate. But if you assume they all have the same API shape, I don't think it matters whether it's per time unit or not.
Yeah, and I mean concurrency is you're allowed 3 things at a time, which means that there is this notion of time, but it's really like delta t is 0. So I'm just like concurrency and rate are kind of the same thing. Just it requires a bit of a stretch of the language.
Or physics.
Squinting.
Yeah, I think it's quite a stretch to call a concurrency limit a rate limit. Like, maybe I don't know. Like, the 0 unit of time didn't do much to convince me there.
A throttler is better. I mean, it's a throttler, but throttler feels. I don't know. It's not a thing I say often. It's like throttler.
Right, but that's resource throttler instead of resource limiter, and I think the objection is against resource, not limiter.
I see. So,
Right, so-
a new noun, you mean?
Yeah.
Like thing limiter.
Yeah.
So,
And
as a little bit more background is we also kind of looked at what similar types are in other languages. Most of what we've seen are literally called rate limiters because they are purely a time-based rate limit. And the difference here, why we try to kind of avoid the same naming, is because we want to communicate that this is, in addition to rate limits, a combination of that and concurrency-based limits. So that's why we kind of started looking for different names. But that's a little bit of the background on why we're proposing resource limits.
yeah, I mean, I would also kind of ignore that because I think in practice, like when people look for an API, if you think most people want to start with rate limiting and then maybe they expand later, they will look for rate limiting and then they can learn about the API and then, oh, neat, it does more. But the problem is I wouldn't necessarily say, don't use the naming of your technology as positioning as our stuff does more than the competition, because that's not how people think about stuff when they start learning, right? And realistically, when you look at any given feature, what you're mostly, no pun intended, but what you're mostly limited by is how many people are able or willing to use your technology, right? So optimizing for people learning about it, getting started and quickly understanding what it is and how it works is far more important than optimizing for the person that already understands most of it and now pushing the envelope, right? Because for those people, naming doesn't matter anymore. They know what it is, right? For them, it's not, the naming has lost all its meaning. It's just now that's the name of the technology and it could be replaced with anything else. So that's if everybody else calls it rate limiter, I would just call it rate limiter and say, hey, cool, our rate limiter maybe does more or less, right? Depending on viewpoint, but just pick the name that is kind of the industry standard.
Yeah, fair. I agree with that kind of I guess analysis. Just one kind of caveat to that is I don't want. I think there is a risk of essentially seeing the name as rate limits and construing as it can only be rate limits. That might be how people essentially think about it, and it kind of signifies a or suggests a smaller subset of capabilities that it can potentially have. That's the only thing I see being a little bit risky here. I don't know if that's a important.
But what's conceptually the difference between a concurrency limiter and a sliding window rate limiter, where you don't get to know what the window is? Like you just call acquire, and you either get a thing or you don't, which is why you think that the unifying the two things in one class is reasonable. But again, from a while you can talk about it in terms of threading or whatever, Like a, a concurrency limiter is just it's a it's a hard unit of time to talk about sliding window limiter, where the window is as long as the longest request is.
That's
you're
the key
proposing-
difference, right? It cares about the length of the request, right? And
Sure.
rate limiters typically don't ever.
But you don't know when you call acquire yet, right?
Yeah, like the caller just knows that they're acquiring something that, or they're calling acquire and that it could fail. They don't know why it fails. Like the bandwidth thing totally. Well, sorry. With the bandwidth thing and stuff, you need to have an agreement of what you're doing. The notion of that you just have the acquire 0 as a, or sorry, acquire 1 as an easy call. Like, there's a thing, I want it. Like, concurrency or 5 requests per minute or the 5 requests within the last 30 seconds. Like, they're all the same thing. But they're all, again, it really is rate. It's just the notion of time is what gets weird.
Right.
So you'd say 7.4 slim's the rate limiter?
It limits the access to, in at a time. Like, so yes. In my mind, it's a rate limiter.
Yeah, if I feel like I'm not like I want to clarify that I'm not against the use of the name rate limiter. It's just we do need to be aware of the fact that essentially we're saying that concurrency based limits are a type of rate limit. And if we agree with that, then yeah, I think rate limiter would be a good name for it.
I mean, I guess I just don't see the difference. I mean, because for me, like if you look at the abstraction, if they both go through the same abstraction, it seems to me at that point you're just kind of like semantic nitpicking kind of thing where I would say once you reach that point, probably the 80% name is probably the right name, right? Because the absolute correct name then becomes some super abstract concept like system.acquire or not, right? Which is no longer usually that interesting, right?
So we should use the wrong names, what you're saying.
I think if your name is only 80% right, you probably pick the best name, yes. Like 100% correct name is
Yeah.
terrible.
So, sorry, Stefan, you were saying?
I was being pithy. I said we're the BCL, we get to redefine it.
Okay. Maybe. Okay, so let's operate under the assumption that I'll rename this to rate limiter. I think there were discussions on estimated count, and I haven't heard anything about acquire wait async, but we should probably confirm those namings well.
So I don't know enough about the derivatives, but is everything you have fundamentally bounded? Or there's some open-ended? So like, is everything bounded? Like, is there such a thing as a total number in a given system, or?
Right. So let's give a couple of examples. Two of the proposed default implementations. One is a fixed window rate limiter. So in that, how it works is you say, I am essentially calculating my window as, let's say, 1 second, and I only allow 5 resources in each window. So in that case, when you do that, it means you can only have 5 operations per second. You can extend that to 5 operations a day, or 100 operations per second, or whatever. But that is essentially how you define a fixed window rate limiter. And essentially, once that window elapses, your resources refreshes to whatever the max limit is. So that is one of them. The other one being concurrency, which we've been kind of talking about. Imagine that as essentially a semaphore slim that you can kind of acquire multiple resources in one single chunk, essentially.
Yeah, I guess what I'm unclear of is like, I mean, I think we talked about this last time, right? When we said like, an int is good enough because, 4 billion or 2 billion of something is probably enough to model everything, right? But I was thinking of like what uh, David was talking about, like bandwidth kind of limits, where you would basically acquire the reads and writes, in which
Mhm.
case you kind of want to pass in the number of bytes.
Yeah.
Right.
And at which point, like, I guess if every single request is just talking about one buffer, an int is probably enough, practically speaking, because you can't make arrays bigger than it anyways. But like, is that always a model where we can basically squeeze every possible resource into basically what amounts to an int, and we can say, yeah, they're countable?
Right, and the other thing we talked about is let's say your base numbers are really big. Let's say you operate on gigabytes of memory and normally, and you're essentially passing in like roughly 2 billion every single time. In those cases, you should scale that count uh, back to something that's reasonable. So if you're always working with gigabytes, you probably shouldn't pass in a count that's, a
Number of
byte at a
bytes.
time. Yeah, it
Yeah.
should just like the request count should represent 1 gigabyte. Like you're
Right.
scaling that chunk, essentially. And that is why we kind of went from long to int because it made sense to me that that you should scale it to something reasonable, and ints can be scaled to whatever.
Yeah, I mean the problem with that, just thinking it out, is something like cooperative socket. Uh, it it needs to know that's what a count means, right? Like it's the same. It's the same. It calls acquire and passes an int, but it really needs to know what the int means.
Yeah.
So a thing that looks like it's a general purpose API is actually very special cased, and that for nice socket, it would probably want a wrapper over top of this, which was a bandwidth limiter, which took a long and then called into a thing that represents what its scale is to call down to acquire, and that
Yeah.
the problem with being super general is once we say oh, you can be a tenth of the CPU processing or whatever, like you're now very special purposed. Maybe the same concepts work, like you're just a sliding window thing with a maximum concurrency or with a maximum thing of 10, and like that works and you just know what your resource represents, but it's not, it doesn't let you write a socket that is bandwidth cooperative against arbitrary limiters. It's everything now becomes really tied to an application in these cases really needs to know both what its count
Right.
represents and what kind of limiter it's using.
Yeah, and that is the kind of expectation we have. Essentially, in terms of prior art, we also have the memory cache that has a size, but that size doesn't just mean bytes. It's just whatever you define it to be. So there is this kind of at least a little bit of prior art in saying the users must understand what the counts actually represent.
I mean, yeah, I mean, I'm not against it. It's just that, as Jeremy said, like and this is where I'm struggling with the mental picture of like where these abstractions are being used, right? I mean, one thing we know in the BCL that is very hard is like, you can always define an abstraction, but you really need to judge that abstraction by its consumers and by its implementers and like how much knowledge each side has, right? And very often what you find is that when we design something, we only look at one of them, not the other, and then the resulting abstraction usually isn't as good as it should have been, or wasn't even necessary, right? Like iClonable comes to mind, right? There's no consumer for iClonable, right? It doesn't make any sense. So there's an argument here for like, if we understand exactly who the consumers are, like, do they know how to scale the int in all cases? But if it's passed through, it's fine. But like, I mean, I'm having a hard time imagining generic ASP.NET middleware that would deal with a resource limiter when you don't know how to compute an int to pass to the underlying thing to do it, right? So now you need some sort of other mechanism that gives you the scale representation, right?
Right. So, as a couple of examples of how we're envisioning it being used, and some I guess details on the proof of concepts. So in ASP.NET Core, the count represent one request, and essentially when you acquire in the middleware, it's always one.
Right.
In the samples I've been kind of trying with channels, it's just essentially one message or whatever your T is. In
Right.
pipelines, it'll be bytes because you're shuffling around essentially bytes. So that's what that int would kind of represent. I'm not sure if these samples are sufficient for you to kind of illustrate those uses. But that is kind of at least like 3 of the ones I think that could be relevant here as strawman.
Yeah, I mean, I think it's just interesting because basically what the middleware for the ASP.NET would then say is it accepts any resource limiter that believes that one or that the one request is one resource.
Right.
And so then the fact that it accepts a limiter means it needs to say how it intends on using the limiter, which
Right.
feels sort of backward, but is probably fine. But that goes with the same thing with the cooperative socket needs to describe, oh, I pass kilobytes or I pass bytes or whatever, and so it becomes the I'm cooperative with a limiter that understands my sense of scale, and or my unit and sense of scale, which I guess are the same thing. And so it's fine. It's just it's an interesting documentation thing.
Right.
And so with pipelines, if it's measuring, we're now back to the int question. If it's measuring bytes, but pipelines support pushing a sequence at a time, which I don't remember if they do or not.
Oh,
then that means the int now has to become long, or pipelines can't express what's going on, and then now we're back to like, well, do we really want it to be long?
I forgot about pipelines. Fucking long.
So, but why would it be long? Like, isn't the idea you would still kind of? I mean, there's still buffers, right? The buffer is long size, right? So you would still deal in whatever is convenient for buffer sizes, right?
If it's doing the waiting one, then it would work. You would just be, one page push at a time or whatever. But if it's
I think you're right. You can't. Well, can you?
The overall one, if pipelines just have a like go push this read only sequence, like that acquire call has to pass something of is it allowed to do it?
No, well, you would have to. You would break it up, right? You would walk the sequence, and then each individual sequence you do your acquire lease, right? For because you're not writing the whole thing at once anyway, right?
And that's why I said it makes sense for the wait one, because that one you can do sort of piecemeal and like, oh, I need to queue now and whatnot. But the like, I don't know. Maybe it makes sense. It just feels a little weird to me. If it fails in the middle, how do you communicate that?
Right.
I have one more thing. So we got 10 minutes left. John, do you have the generic version in there?
I do not have it in the API proposal issue, but if you open up the design doc, it'll there's a blurb about it there.
So we should at least talk about it a little bit.
Sure.
Just to talk about the thing we spoke about, where there are kind of two. There's the generic version and the non-generic version, and they're not related, and that's a bit weird.
Yeah. So I don't have the sample showing what we talked about offline on Friday yet.
That's fine. That's fine.
Yeah. So if you take a look at go down. This is just a ton of use cases and implementation things. Okay, actually, let me.
Good job, John. Hide it from the API review. Good move.
That was not my intention. I think I put it under a details thing that you need to expand. Let me just open up the.
Here we go.
Oh, you found it?
Well, no, that's
sorry,
a channel.
Else.
That it. Yeah. Sorry. Let me find.
You solved the problem by deleting
It's
it.
called aggregated limiters. So search aggregated.
Oh yeah, aggregated. I see. Yeah. I remember now.
Well, the sample is gone though.
Why do I see it?
It might be you're on a specific SHA. Maybe you need to like. I don't know.
Oh, I see. Okay. Yes. Sorry about. I realized. Yeah. When I linked it, it's to a specific shot, so it didn't have the latest one. My bad. Let me just send that via a chat, so you have the updated doc. So this doc I've been writing is still in PR, so that's why I
Fair enough.
didn't. I didn't realize that it did that SHA thing locking, I guess. Here's the link to the latest one.
Yeah. I'll say I also already put in my note that for the estimated account or estimated count slash whatever it gets renamed to, it should be a method, not a property, because you absolutely don't want to write for I from 1 to this thing.
What?
Sorry. What do you mean?
You would not want.
Why isn't it a property?
You would not want to say. Right? Like, that looks sane because properties generally have that behavior. But it's not because every time you bump I, that thing is a completely different.
Different, yeah.
So it should be a method to encourage you to call it once.
Really?
Yep.
I mean, we have some bad examples in the VCL, like daytime.now, right? But
Didn't we just add this to channel? Didn't we just add like a count and a can count the channel?
I think you scrolled past the aggregated already, so.
yeah, search for aggregated.
Yeah,
There we go.
We made a similar change to the pipe.
We had the same discussion though.
Yes, but it didn't seem like a thing that would be anything anyone would ever really want to put in a for loop.
No, you wouldn't do that anyway. Yeah.
But an estimated availability, I could see someone being like, "Go create an array," and then walking the availability, go do some stuff, and it's like, well, you need to tell them this is a number that is this type is inherently concurrent. Don't depend on it.
Oh, one more quick thing before we take a look at these aggregated limiters. So another concern I was thinking about with regards to naming to rate limiter is does that make sense, like with counts that you pass in, like what does that mean for rate, and also a rate lease, does that those kind of things make sense? Because like a lot of these naming like leases or request count, they made a lot more sense when we were thinking about resources. But when we're talking about rates, either those names also have to change, which I expect they have to be, but is there a sane name for those when we're talking about rates?
I mean, rate limit lease is better than rate lease, but yeah.
Yeah. Anyway, just kind of like food for thought. But yeah, about the aggregated limiters. So the motivation behind this is, for example, in some cases we have very high cardinality limiters. So let's say you're writing a middleware and you want to rate limit based on the remote IP. With just the vanilla resource limiters or rate limiters, you have to potentially keep track of one limiter per IP, which is that's a lot of limiters, and it's we are concerned about having to allocate one per IP address, and that being hard to scale, or it doesn't scale well. So we came up with this other aggregated limiter where essentially, in addition to all of it is similar to all the APIs that are in rate limiters, but you also need to pass in a resource ID for all of the APIs. So estimate, count, acquire, and wait async, they all take in a key essentially that indicates essentially a resource. So that is the motivation behind this. However, there are some tricky bits to this as well. Is for example, resource lease will probably need to be a resource lease of another type, because we need to store a reference. Potentially, we need to store a reference to the limiter itself on the resource lease. So that's another potential like gotcha. And also, like, is this shape for the API for these kind of use cases a reasonable design? The reason why we didn't propose this or didn't include this in the API proposal issue is because so far we haven't seen any use cases of this inside the BCL. It seemed more of a higher level concern, so we were considering using this or shipping this as part of ASP.NET Core alongside the middleware. So this is something we need to consider, but it likely won't be in what we include in .NET Runtime.
Well, so we should talk about it because it does feel weird to have another abstraction
Right.
that has no relationship to the other one at all.
Right.
There's no derivation. There's no nothing. We should talk about that a little bit. It's kind of a sibling title with a whole different hierarchy.
I mean, in a sense, it's kind of pointing out the issue I was trying to express earlier of kind of like so basically what you're trying to do here is not splitting the resource limiter, right? What you're really doing is you're splitting the count, right? I mean, you could imagine that instead of having the resource ID as a generic parameter, you can just think of it as a bit mask over the count itself, right? But you basically take your IP address range, you bucketize it into buckets, and that's part of your int, right? But then, int only being 32 bits, I can see that not being something you can scale, especially when there's, a large number of values per bucket potentially, right? But that's why I think it's a bit weird that you modeling it as a different limiter rather than modeling it as a different thing you're requesting, if that makes sense.
Yeah, it almost you can almost squint and kind of see T key as like another thing to another input, like I guess resource limiter kind of context kind of thing, where you can pass in additional information on the essentially per request to the resource limiter. But I mean, the original motivation for this is to essentially allow rate limiting based on IP addresses or IP address buckets. So
yeah, so basically every time you take a requested count, you now take I guess, yeah, well, basically every time you talk about counts, basically also have to take T key.
Yeah.
But then this does impact whatever your lease type is, because this proposal suggests using the same lease type, but there was nowhere to put the resource ID for your dispose call.
Correct.
Other than the ubiquitous state.
Yeah. Exactly.
Yeah.
So yeah, as David mentioned, having these two kind of parallel abstractions makes it kind of difficult to work with, and also like we wouldn't have. It's not reasonable to ship like default implementations for these aggregated limiters as well, since you don't know what T key is. Or we could constrain it to potentially be like IA comparable. I think that allows potential usages in dictionaries, but yeah.
Though actually, regarding resource lease, if resource lease changes to be the using a long to identify its state, then that just means it's up to the caller to be able to track it back to the key. So it wouldn't actually require changing the resource lease type if it's already based on just an identifier.
Is T key usually a value type, or is it usually a class?
I think it's usually IP address, so whatever IP address is.
That's the one we have identified, but I don't see why we would like what's the benefit of constraining it?
So,
So you can use it as a dictionary key.
well, one thing you could do is instead of, as I said, instead of having a completely different abstraction, you just basically change the chord where you basically have effectively a struct that you pass in instead of the int. So effectively you mix the key and the thing into one struct, and then you have like that struct basically holds onto an int and an object, and that is strongly typed to whatever you want it to be. But that means if it's usually a value type, you end up boxing. If it's usually a class, then it doesn't matter.
Yeah.
But that would basically mean you get rid of the dual system. You just have one resource limiter, and that takes a request unit that happens to be an int and some other piece of information.
Well, if it was a rate limiter of t, and the acquire took some struct of t, I guess the problem is that because if that struct had a count plus the t state, then you're back to what does the simple one use for t? And I was gonna say it's obviously int, but then you have the count and the count together, so that doesn't help. Never mind.
Well, you would just have the count and null for the key, right?
Right.
Logically,
It's like a
right?
void.
So now you're back to wanting to use void as a generic argument.
Well, that's why, as I said, like I would probably just, in this design, you would just have resource limiter, but instead of taking requested count, you would take some struct that basically holds onto the key and the int, right? And then you only have one abstraction.
Yeah, it almost sounds like you want a request context or like a resource limiter acquisition context or something like that. Yeah.
Yeah.
Why don't we
probably
make
call it unit or something, but like, yeah.
Yeah, and then let's have state on there too, so you can add whatever you want.
Yeah, this is the problem with like when you go down the, solve world hunger with an API. But I mean, so what is the problem with these two different things? Like basically the resource lease doesn't have enough data on it. Is that the problem?
Or the concern is that we don't want to essentially need to allocate a limiter per like these high cardinality cases.
No, I'm
And we want
saying
to-
what's wrong with having the separate type? Like basically the proposal you're having, like you said, there's some issue with the abstraction.
So the reason, like what we don't like about having these two separate types that essentially don't have any relationships to each other is that like how do you as a consumer, let's again using the middleware as an example, how do you use both in a consistent manner? Like you
and
essentially
you have to rewrite, you have to rewrite the implementations, both generic and non-generic, and they can't be shared. That kind of sucks, right? Fixed window, bucketed, all that stuff.
and then you're essentially trying to cast, or like you need to try different types. It's like, oh, okay, so this time I got a limiter, but this time I got an aggregated limiter. Now I need to,
Wait a second. Would an aggregated limiter not take in like the per key limiter as like a constructor argument or something?
It should be a function.
Or like a factory, yeah.
Right. So I do think that makes sense. Then the question is this even an abstraction, or is it just like a thing that can bucket for you, and then the factory creates per bucket resource limiters? So it's not really a thing you need to change per se.
I mean,
I think it's
part of an
I mean, it must be the other way around, right? Because I mean, at the end of the day, you can't delegate to a limiter, because otherwise you're again stuck with one limiter per IP address, right? You would have to say a normal resource limiter is an aggregated resource limiter of size 1, right? Where you only have one bucket.
Yeah, or it's the aggregated resource limiter is a dictionary of filtered to key to resource limiter, and it just then creates one every time it sees a new bucket. And so this is fancy dictionary of to key to resource limiter.
Yeah, I think the implementation ends up being fairly small, but I still think you want it from the VCL.
Exactly,
So,
and yeah.
I'm confused. Are you saying this is logic? Because I mean, it can't be physically, right? Because the whole point was that we don't want a resource limiter per IP address, right?
Right. I mean, like you could simply model, or you could model it that way, but now you do get, if you are doing a this IP address is limited to, or you're limited to 5 requests per second per IP address, then now you have 2 to the 32 uh, different instances of your acquire, assuming you saw the whole range of IP addresses. And then IPv6 also happens, so good luck with that.
Or you add more generic arguments, and you get a T key to T bucket, and you ask the person to pass in a func that kind of goes from the key to bucket, so it can kind of pick how they want to bucket things.
I mean, that's what iComparable is, right? But I think that
iComparable.
I mean, that doesn't separate the data structure and the function, but it is,
Yeah.
right? Like iComparable with T. And you could write your own. But yeah, it's an interesting point. So could the T key thing be the entire abstraction, I think is the question, right? Like, do you even need the keyed version of resource limiter? If all the efficient implementations are going to internally do something smart anyway?
I think you want the non-keyed version. I just wonder if this thing is an abstraction or just a concrete thing that lets you parameterize resource limiters based on the key.
I mean, if you say we don't want to proactively create them and we're okay with laser initializing one limiter per IP address, then yes, I can see that working. If the whole point is you want to literally virtualize it and say there is no limiter per IP address, there's just one uber limiter that through some sheer magic of bookkeeping knows how many IP addresses it has, so it doesn't actually allocate a limiter per IP address, then I think that's a bit harder because that one would be specific to whatever resources is that you're bucketizing, right?
I don't see how this design precludes either, though, right? Like, the simple thing would be the dictionary-based approach that lazily creates the non-keyed limiters. But if you need better performance for your IP rate limiting, this doesn't stop you from trying.
Well, I mean, I think the problem is still if in the current design you basically have two different ways resources are being maintained, and there's no relationship, right? Ideally, you want to be if you want to write generic code in the middleware, you want to be able to treat one through the other, right?
Well, if we take Corey's lease idea, smarter lease, the factory, almost all of the actual consuming code would be interacting with the release, and it would only be the initial require with the resource ID that would be the difference, how you get the lease to begin with. But anyway.
Well, I don't think that's true because I mean, in that model, you would have to take the call to acquire, put it on lease, and that one is the one that takes the T key, right? So shifting it just down to a different type.
Well, I think it's a different resource lease type would know to have included the IP address. But you're back to the same problem of how do you know how to get one of these? And if you say that I'm taking an IP based concurrency or an IP based sliding window limiter, you had to build an IP based sliding window limiter request, and now you're not pluggable anymore. You've locked yourself to an implementation. So I think that Corey's inversion thing, while it solves some API problems, it eliminates ASP's pluggability.
Wait, how have you locked yourself into implementation? You can use DI and open generics, and as long as the keys are comparable, you can replace the limiters, right?
I mean, if you need to get a resource lease request that takes an IP address, you need something somewhere to know that you need to pass an IP address.
But it doesn't need to be the limiter. Yeah, there's been some talk offline about how to basically tell the limiter that you're interested in IP. But yeah, it's an interesting point.
Yes, the caller needs to know how to pass the context, and once they understand what kind of thing takes this kind of context, they've basically picked their implementation.
But I will say that just grabbing a resource limiter of IP address out of DI already communicates some things. But yeah.
Well, that goes with this approach, yes. Of the I want a IP-based aggregation limiter, and I'm going to call acquire with here's the IP address and one. That works with this one. I don't know how it works well with the other one.
Sorry, the other one?
Where the lease understands all the state and then you lease has acquire, which turns it into you're now a held lease, and then dispose does whatever dispose feels like doing, and the caller can manage the object to their heart's content. Like somewhere that needed to know it needed an IP address, and I don't see how that would work. But maybe I just don't have a good enough vision.
Yeah, so essentially that was Corey's proposal or recommendation, and you can kind of see it in the chat where you create a resource user and then that thing acquires.
Right, I just don't see how that would be able to do an IP or any other
Right.
context one.
Yeah, that would be difficult. Yeah,
Unless you
I
make
guess.
resource lease generic. Yeah.
No. Okay, that's
I'm
fine.
kidding.
No, but yeah. So like I understand how it would work in if you don't mix in the contextual ones, but once it gets context, you're back to how does the middleware know it needed context and what that context was, and how does it get one of these requests to ask the random ambient state of the process, like, hey, does anything care to bucketize by this? And then what does that mean? So it gets weird, at least in my head. All right, so we are well over. I don't think I have any notes for this part because I don't think we talked about anything concrete.
I mean, this is, I think, part of the problem here. It's like without actually understanding how you want to treat those, it's a bit hard to say. I mean, I generally agree with Fowler's assessment because that was the same question I had. Whenever I see generics that are not related, it's bad because you force bifurcation.
Yeah.
I mean, if you have an abstraction, you kind of want to be able to treat one as the other. And what that flow is depends on your use cases. But it does seem to me that it kind of pokes a hole at the idea that everything is an int. That to me is kind of the higher order bit here. It's kind of, you realize an int is not enough for modeling all you need. So you have this thing on the side, and that we now model as this fairly heavyweight thing. You know, the question is is this sufficient? I mean, presumably with a generic, you can do whatever the fuck you want. So whatever state you need to smuggle in to acquire leases, you can do now. But now the question is that really the core? Or is the other one the core one, right?
Right, but
Yeah,
now you're back
exactly.
to the middleware asking DI for, I would like a resource limiter of int, and hoping that someone gave it one, as opposed to
thanks.
I want the resource limiter, and it's like, here's the resource limiter. Like,
I mean, that's a good point. I mean, you could literally say like the int is the instantiation, and then say like, you know, the IP address one is it's some other struct that takes the IP address and the count, and that's your actual T key, right?
it could be,
So it's
but
not a
again,
T key, it's more like a T unit at that point.
yeah, but that means that basically you have to, yeah, it's back to the now you have to re-implement things because the T changed and you can't. Even if we have generic math, you're not going to be able to generic which property off of this struct did you care about to go do generic math for. It was 3 too many. So
You need more funks.
So
I feel as though we should
Yeah.
have an example of this one, John, for next time when we come back.
Mhm.
Yeah.
Sure. Like, I can kind of point to how we're using, how we're implementing a IP aggregated rate limiter inside the middleware sample I've been working on. But yeah, I was kind of throwing this out there to get people's kind of ideas on like what
another
shape this
interesting
should
thing to
take.
compare this to. Oh, sorry.
Yeah. Go ahead. Sorry.
And I think Jeremy brought it up at the very beginning. And Dave's going to reek his allocations, but there are ways to avoid it. It's like compare it to an iDictionary of like T key to the normal resource limiter and how that would be used. Assuming that was like registered as a service or something very close to it. I guess maybe not that, but you get what I'm saying, right? Like maybe it's just a method that takes the T key resource ID and returns a resource limiter.
Yeah. There's a couple of composing options of how they could essentially kind of be built on top of each other, so to speak. But there were like none of these feel very, I guess, natural. It feels you're kind of just like you have two separate things that you're just, wrapping against each other, which is may be fine, but not sure if there's better options we can explore.
Yeah, and they're easily like translatable to another. I just kind of wanted to see the usage, but yeah.
Yeah, the composed call, like Stefan, at least what I heard when Stefan said it, of that somewhere there's an aggregator, and you're like, aggregator, give me the rate limiter for this context, and now it just gives you back a rate limiter.
Yeah.
You can do complicated object reuses and stuff for tying that context in, but
Yeah.
yeah.
I
Yeah,
kind of prefer that actually.
Yeah, I think like way back, like a month and a half ago or 2 months ago, that is kind of how I uh, use these APIs, but it was kind of brought up that, oh, we don't want to map a T key to a resource limiter, so this was the result of that discussion. But
Indeed.
we might need to revisit that.
Yeah, I mean the other thing is what would writing the IP based limiter look like here, and how sad would you be that you have to go rewrite it for all the different algorithm types that you've already discussed for the
Oh,
context free
yeah.
one? And
I don't think that's too bad because you kind of just uh like it shouldn't be too difficult. The main concern was that each limiter might be too heavy. Like it might have, imagine the case where we're essentially saying, resource leases have, an ID that tracks back to keeping track of things. Then essentially each resource limiter almost need like a dictionary of IDs to, I don't know, some kind of state. If that were the case, if every limiter had a dictionary, do you want to allocate like all of that in, for each IP address? Or essentially what this allows the aggregated resource limiter is you have one dictionary, but it keeps track of like a ton of different, I guess, resource limiter states.
right,
So,
I mean the
so
thing you would
that's
do is the object return back from get it for this metadata key is that it's an object wrapping the dictionary from that shared across all the different things that could be returned back from this one aggregator. But like you can do it, it's just more plumbing. But okay.
Yeah. Anyway, so I think the next, when is the next opportunity where we can kind of circle back to some of these discussions?
I mean, it's mostly a function of like when do you think you will be ready to present, because I think that's, I mean, we meet basically several times a week. I think we're now down because we don't have to review as much, but we can meet basically whenever you need to. Our usual slot is Tuesday. We have, I think, one slot on Thursdays.
This Thursday is analyzers, right?
Yeah, this Thursdays we do analyzers. That was our last big one, I think. And then it's mostly backlog. I think for next week I haven't set up anything yet. So I mean, if you want to, we can just do next Tuesday. That would be the easiest, probably.
Well, I'll try to get address most of these comments by Thursday. So if miraculously we have time, I can kind of continue the discussion there. But yeah, we can say Tuesday for now, but maybe even earlier.
I mean, we will definitely not have time to talk about it in
Okay.
depth because we want to kind of use the 2 hours to go through all the analyzer stuff we have. But like, I mean, if you really wanted to, we can set up one for Friday. But like at that point, we might as well call it Tuesday, right? I mean, it really depends on like whether you think you get more out of it or not.
I'll try to. I mean, I'll go through some of this, and if I feel I'm ready, I'll try to set something up for Friday, maybe
Sounds good.
ad hoc thing. Okay, sounds great. Thank you very much.
All right. So I have the notes that I captured, including one that wasn't discussed.
Right.
And
I can
your
always
opinions?
refer back to the recording, I suppose.
all right. So
Thank you very much.
this is needs work, right, Emo?
I think that's usually the way we do it in the tool. Otherwise, like, it
Yep.
doesn't quite work for us. Yeah.
Sounds good.
All right.
Awesome. Thanks a ton.
And all right, so we will be back doing analyzers, as we already mentioned, Thursday, 10 a.m. Redmond time. People who care know how to find us.
All right. Thanks,
Thank you
everyone.
very much.